Hi. First of all, thank you for having me in eCAADe conference. My name is Seda Tuzun and I'm a PhD student in architecture at Texas A&M University. Today I'm going to present our research with Bihan Wang, Yalong P, and Dr. Wang. Our research presents a new framework for web-based parametric modeling for design collaboration. With this new framework, multiple users can work on the shared web-based model in the process of building design and modeling, performance simulation, and optimization. The framework consists of an online viewer which displays a shared web-based model, two visual programming tools, Grasshopper and Dynamo, located in users' local computers, connected to the web, and two prototypes or plugins, one for Grasshopper, the other for Dynamo, were developed for this project to control and modify building models on the web. The prototypes provide real-time data transfer from visual programming to the web-based model. A Revit model was converted into a web-based model. During this conversion, parametric relations were lost, and these parametric relationships were rebuilt within Grasshopper. A twin model of the web-based model was created in Grasshopper in order to guide the user in building parametric relationships, conducting simulations and optimizations, and visualizing simulation results with a colored mesh. Two case studies were conducted on a simplified residential building model. In case study 1, two simulated users, a Grasshopper and a Dynamo user, tested the parametric capabilities on transformations including scaling, translation, and rotation of the shared web-based model. The experiments showed that any change in scale or translate parameters by any user resulted in a parametric change in both users' web-based models simultaneously. The users collaborated by manually updating their visual programming files with the data they retrieved from the web-based model. Due to the complexity of parametric rotation, it was only tested by simulating only a single Grasshopper user currently and worked partially. In case study 2, two simulated users collaborated on the shared web-based model through Grasshopper in the process of multi-objective optimization for different building performance objectives. The roof of the building was defined as parametric, while the rest of the elements remained static. And the parameters of the roof proliferated the intended roof shape and building performance results in an iterative simulation and optimization process. The objectives were to optimize the roof shape creating shading and minimize energy usage or achieve the preferred daylight performance. All the simulation and optimization processes were completed on one user's local computer. By visualizing the optimal solutions in Rhino, the user evaluated and chose the best solution and transferred it into the web-based model, while the other Grasshopper user observed it through his own web-based model and retrieved data from it. There is a major limitation in both Grasshopper and Dynamo. Their number sliders of parameters don't allow to be updated by external data, which requires users to manually update in visual programs after each change done by the other user. Two major interoperability issues were identified between the web-based model and Grasshopper. First one is the difference in the reference points of transformations. To align the transformations, the twin model method was used, which is the reproduction of the web-based model in Rhino. It serves in calculating the displacement between the initial and the last positions. The second interoperability issue is the difference of the directions of rotation between the web-based model and Grasshopper, which was overcome by flipping the angle inputs. With this framework, multiple users have the authority to edit and view the shared web-based model. Future work includes examining first, editing geometry vertices of the web-based model. Second, the automation of the reciprocal data transfer, which will help divide and distribute the optimization process to two or more users according to the multiple design objectives for collaboration. If optimization is divided and distributed, users can collaborate and optimize simultaneously by sharing parameters. This way, the process would be more efficient and effective. Third, the elimination of the need for the twin models and enabling direct modeling, simulation, and optimization on the web. The framework provides a free and open platform for working remotely and could also be utilized as an online educational tool for architecture students. This is especially important during the current COVID-19 pandemic and future similar situations. Thank you.